And welcome students as we get into our next lesson. Today we are going to be discussing writing to a text file. So we kind of discussed previously some differences between that of a text file and a binary file. So let's jump right in. So the first thing we need to discuss is this thing called print writer. The class print writer is the preferred stream class for writing to a text file. Now, an object of the class printWriter has the methods of print and printLine, which are just like the methods of system.out.print and system.out.println that you can use for screen output. I'm not going to throw those method definitions up here because they're pretty self-explanatory. Now, however, with an object of the class printWriter, the output, instead of going to our screen or to the console, it's going to a text file. So if we look at our text file output demo, we're going to see a simple program which uses printWriter to send output to a text file. Let's take a quick look at the details. So if I take a look here, I have a couple import statements here. So there's print writer, output stream, and file not found exception. You want to make sure that this one right here is always here because if you don't have your file there, it's going to cause issues. But here's print writer, and file output stream is what actually does the writing. So here you can see we create our print writer object. This is very similar to how when we make like our scanner object, we have to create scanner keyboard because new scanners is not in. Here we take and initialize it to null. Then we just use the try catch block to pretty much test to see if the file is valid, if we can create that file. And then afterwards we can then do some simple commands here. We can say writing to file. Here's the output stream that actually writes it to the file. We close the file and then we say end of program. Now if we take a look in here, you'll see that this is the text output demo file, and you can see in this folder there is no text file right now. All right. But I'm going to go ahead and I'm going to run this program real quick here. It says writing a file and a program. Now I should have created this stuff.txt file. So if I look, you see I now have a stuff.txt file. And if I open that txt file up, you can see there's my text that I had in my program. And if I go back to the program, I can choose to run this again, and it will just do the same thing. It just overwrites. So if I change what was in here, it would simply just overwrite whatever was written in that text file. So let's first analyze the pieces of it, starting with java.io. Now all the file IO related classes we introduced in this chapter are in the package java.io. So all of our program files begin with import statements similar to the ones in text file output demo. So the program creates a text file named stuff.txt that a person can read using an editor or that another Java program can read. In case in point, the stuff.txt file. We can open that right up. Hey, look, we can read it. It's normal text. It's not binary. It's not gibberish. The program creates an object of the class printWriter as follows: output stream was new printWriter, new file output stream stuff.txt. All right, and we saw that in our program. Now, when we actually talk about opening the file, the variable output stream is a type of printWriter and is declared outside of the try block. If we put it inside the try block, that means it possibly could not exist. So you want to make sure that you declare it outside of the try block. Now the preceding two lines of code connect the stream named output stream to the file named stuff.txt. This is what's known as opening the file. When you connect a file to a stream in this way, your program always starts with an empty file. If the file stuff.txt already exists, the old contents of stuff.txt will be lost. If the file stuff.txt does not exist, then a new empty file named stuff.txt will be created. So this is how you can go about and create your text file, and you don't have to worry about, oh, did I overwrite it? It's kind of like when we run a program in the console and we can clear out the console. It's kind of the same similar idea here. We're overwriting the text file. We're, whatever the previous version was, it doesn't matter. We're just overwriting it. All right, let's discuss the file output stream itself. We want to associate the output stream with the file name stuff.txt. However, the class printWriter has no constructor that takes a file name as its argument. If you actually were to go into the Java documentation, look at printWriter, you will see that it is just like an OR constructor. So we use the class file output stream instead to create a stream that can be used as an argument to printWriter constructor. Therefore, our expression new file output stream stuff.txt takes a file name as an argument and creates an anonymous object of the class file output stream which is then used as an argument to for the class print writer's files. New print writer, new file output stream, stuff.txt. And like I said, it's not really an OR constructor. I think I might have said that a little bit here earlier, but you can't just put new print writer stuff.txt. It's because it doesn't accept that. But you can use file output stream, and that will work just fine. All right, now reading the file name, this, of course, if we run the code that we just saw, it's going to produce an object of the class print writer that's connected to the file stuff.txt. Now note that the name of the file, in this case stuff.txt, is given as a string value, and so is given in quotes. If you want to read the file name from a keyboard, you could read the name to a variable of type string, and use the string variable as an argument to the file output stream constructor. All right, now we need to, of course, discuss file not found exception, because this is a very important exception to be had within that of input and output. When you open a text file in the way just discussed, a file not found exception could be thrown, and any such possible exception should necessarily be caught in a try block. And it's not the print writer that does this, it's actually the file output stream constructor that throws the file not found exception. But ultimately, the effect is still the same, whether you're using print writer or the output stream. Now, you'll notice that the try block in text file output demo encloses only the opening of the file. That is, the only place an exception might be thrown. Right, so if we look at our code, you'll see that only the output stream here, the actual construction of this, is in the try block. The rest of it's not. I mean, yes, you could technically do like nested try blocks and stuff like that, but this is the only part that could technically throw the exception, so it's the only part that has to be within the try catch. You also note that the variable output stream is declared outside the try block, so that this variable can be used outside of the try block. Right, which of course is the output streams right here. Because I could technically say try print writer output stream, it would be valid. But the problem is if I don't have it, if it's inside the try block, we could run into issues. Now, remember, anything declared in a block, even that of a try block, is local to the block. So that's why I have to declare it outside of it. All right, let's actually now look at opening that text file. So we can create a stream of the class print writer and connect it to a text file for writing as follows. Print writer output stream name, output stream name equals new print writer, new file output stream file name. We can use the methods print and line and print to write to the file, and when used this way, the file output stream constructor and thus the print writer constructor invocation can throw a file not found exception, which is a type of I/O exception, which leads us right to some of our next stuff. All right, first off, file names. The rules for how you spell file names depends upon your operating system, not on Java. All right, so like let's talk about things like different file conventions, the characters you can use. When you give a file name to a Java constructor in a stream, you're not giving the constructor a Java identifier. Right? This is all things based upon your operating system. Instead, you're giving the constructor a string corresponding to the file name. Because if you notice, it was like stuff.txt. Stuff is the name, txt is the extension. You have to put the whole thing in there. You can't just say stuff because it won't know what type of file it is. A suffix such as txt has no special meaning to Java. Java could care less if it's a txt or RTF file or some other type of file. It just knows, hey, there's a file there that matches the name that you've given me, or there isn't a file there that matches the name that you've given me. That's all Java really cares about. Now you're using the suffix txt to indicate a text file, but that's just common convention. You know, there are other ways of doing things, but we're going to stick to text files because they're simple, they're easy to use, and it's not going to require us to handle a lot of complexities. Now, you can technically use any file names that are allowed for your operating system. For example, you can use underscores, you can use dashes, letters, numbers. Can't use certain characters on your keyboard in a file name, and so just because Java might let you put a string with any kind of name in it, doesn't mean that it's going to be valid for your system. So you got to make sure when you create that string inside of the constructor here, that that string is a valid name that can be used by your system. Now, a file actually has two names. Every input and every output file used by your program has two names, which is, of course, the real file name that's used by the operating system, so like stuff.txt, and the name of the stream that is connected to the file. The stream name is what serves as a temporary name for the file, and is the name that is primarily used within your program. After you connect the file to the stream, your program always refers to the file by using the stream name. So like, for example, output stream. All right, we're going to circle back around now to our file not found exception. Now, we said that when you open a text file for writing output to the file, the constructor might throw a file not found exception. But in this situation, let's say you want to create a new file for output. So why would you care that the file was not found? You're just creating a new file, right? Well, the answer is more that it's simply that the exception is poorly named. A file not found exception does not necessarily mean the file was not found. In this case, it actually means that the file could not be created. A file not found exception is thrown if it is impossible to create the file, for example, because the file is already used for a directory or folder name. Now, when dealing with file I/O, there are many situations in which your code might throw an exception of some class, such as file not found. Many of these various exception classes are descendant classes of the class I/O exception. The class I/O exception is a root class for various classes having to do with input and output. All right, and just lastly, let's discuss print, println, and printf and how they relate here with the output stream. A file not found exception is a type of I/O exception, so a catch block for an I/O exception would also work and look more sensible. However, it is best to catch the most specific exception that you can because that will give more information. It's kind of like just saying exception E. This exception E will catch pretty much any kind of exception you throw, but it's not necessarily designed for a specific exception. All right, as illustrated in our text file output demo, the method println of the class printWriter works the same as writing to a text file as the method system.out.println would work for writing to the screen. All right, when we write it out to the console, it's pretty much doing the same thing, except for instead of doing system.out.println, we're doing the output stream. Now the class printWriter also has the methods print and printf, which behave just like how system.out.print and system.out.printf, except that the output, again, instead of going to the console or to the screen, it's going to a text file. All right, closing your file. When your program is finished writing to a file, it should close the stream connected to the file. In our text file output demo, the stream connected to the file self.txt is closed with the statement output stream.close. The class printWriter and every other class for file output or file input streams has a method named close. When this method is invoked, the system releases any resources used to connect the stream to the file and does not have any other housekeeping that's needed. It's pretty much straightforward. Just say, hey, I just want to close the stream. Done. That's it. Now, if your program does not close a file before the program ends, Java will close it for you when the program terminates. But it's safest to close the file with an explicit call to close. So even though you say, hey, I'm not going to close the file, Java will do it for me, it's really a better practice to put that force close in there because that explicit call is going to make sure that that terminates correctly. All right, that has to do also partially with our next slide here, with the buffer. Output streams that are connected to files are often buffered, which means that rather than physically writing every instance of output data as soon as possible, the data is instead stored in a temporary location known as a buffer. Now, your buffers are typically in your system memory. When enough data is accumulated in this temporary location, it is physically written to the file. This can technically add to efficiency because physical writes to a file can be slow. Memory is a lot faster than that of, say, a traditional hard drive. Now, the method flush calls a physical write to the file of any buffer data, and the method close includes an invocation of the method flush. So actually, flush is like a helper method to that of close. All right, circling back to closing the file. When your program is finished writing to a file or reading from a file, it should close the stream connected to the file by invoking the method named close. So that's pretty easy to do. Just stream object.close. Here's some quick examples: output stream.close and input stream.close. Now, it may seem like there's no reason to use the method close to close file, as we said. If your program ends normally, but without closing the file, the system automatically does for you. We've already mentioned this. And again, why should you have to do the explicit call? I kind of already alluded to this, but there's at least two specific reasons. First, if your program ends abnormally, then Java may not be able to close the file for you. Right? So let's say Your program runs and it throws an error that you weren't expecting. Well, what this could do is it could damage the file, and particularly if it's an output file, any buffered output would not have been physically written to the file. So the file is going to be incomplete. So the sooner you close the file, the less likely that this is going to happen. Second, if your program writes to a file and later reads in the same file, it must close the file after it is through writing to the file and then reopen the file for reading. All right, that's going to wrap it up for today, folks. It seems like quite a bit of information, but hopefully it was fairly straightforward. So we will see you next time.